So this is problem number 9 in the week 8 my math lab work, and what's asking you is to apply some ideas about the central limit theorem and then do a calculation. So we know that the central limit theorem tells us that when I do a bunch of repeated samples of the same size, the mean is going to be exactly the same as the population mean. So in this case, and that's what this symbol means, what's the mean for the sampling distribution? So for this case, it's 134. To get the standard deviation, now we can't just take, and this is where people fall down on this, is we take that population standard deviation and we have to divide it by the square root of the sample size. So in this case, I've got samples of size 100. So I'm going to do 17 divided by the square root of 100, which of course is 17 divided by 10. And that's where I got the 1.7 from. Okay. So the last part of the central limit theorem tells us that as long as we have a random sample, that's important, and we have a sample size that's large enough, and typically 30 or more will work. Well, the distribution will have that for a center, the population mean for the center, this for the standard deviation, and then it'll be approximately normal. And especially for a size of 100, sample size of 100, it'll definitely look almost exactly like a normal distribution. The question D is asking us to find the z-score, or the standard score for a sample of 135 hours. Well, we want to know how many standard deviations away is what this is asking the mean. So the sample result was 135. The population center was 134. And we're going to divide that by that standard deviation of 1.7, not the 17. And that's how I came up with a 0.59. Make sure you do the subtraction so you get 1, then divide that by 1.7. Okay? Part asks us what's the probability of getting a sample with an average of 135 or more. So I went to that normal CDF calculator that I used before, and I'll link to in the forums. So I put the mean as the 134. I use the 1.7 standard deviation, not the 17. And then I want to know above 135. So shaded it for us, did that very nicely, and this is the probability of that happening. Okay, so I hope this helps.